The consecutive angle theorem says that if you have two lines that are cut by a transversal, and those two lines are parallel lines, then their pair of consecutive interior angles will be supplementary. And that's what we're trying to prove here. So we have our setup for our two-column proof. We're going to be proving the consecutive interior angle theorem. So let's go ahead and look at our given and the statement that we're trying to prove. So what's important here is that you're not using the information that the consecutive angle theorem or whichever theorem you're trying to prove what you're trying to prove. So in other words, on your two-column proof, the only time you're going to have your statement, which is what I highlighted, should be at the end, which is when you show that that's true. So let's go ahead and label our two-column proof. The left side we have our statements, and then on the right side we'll have our reasons. So let's go ahead and start with our given. So we're given that line L is parallel to line M. And that's by our given. So let's look at the diagram to see what else that we know based on the information that we're given. So we know that angle 1 will be congruent to angle 3. And how do we know this? Well, since the two lines are parallel, I can use the corresponding angles postulate. That says that when you have two lines that are parallel, which is in this case L and M, then their pair of corresponding angles are congruent. So remember how usually I tell you guys that after the given, we usually use a definition, another postulate, or another theorem to help us come up with the statement after the given. And yes, postulate was spelled incorrectly here, so let's spell it again. All right, so what else do we know here? We know from our diagram that angle 1 plus angle 2, their measurements equals 180. Why? Because together they form a straight line, and we know that straight lines are supplementary. And our reason here will be linear pairs, right? They're right next to each other, which means they're going to be adjacent, or in this case, they're adjacent, and they add up to 180, so they're linear pairs. All right, so I have two different statements here. Let's see how I can connect them. Well, we know that angle 1 is congruent to angle 3. So I can substitute angle 3 into that equation that I have. So we're going to substitute angle 3 with angle 1 with angle 3. And that gives me exactly what I'm trying to prove. And I swap the order. So I swap angle 2 to be first and angle 3 to be second, just because our statement that we were trying to prove is in that order. But you could have it as the measurement of angle 3 plus the measurement of angle 2 equals 180. All right? Since we have the statement that we're trying to prove, that means that we're done with our proof. So now that we're proving that we have proven that theorem, let's go ahead and apply it to this example that we have here. So we're trying to find the value of x. So in this diagram, the two angle measurements that I'm given, they're consecutive interior angles. So by applying the theorem that we just proved, we can set up the following equation. That means that their sum will equal to 180 since they're supplementary angles. And then we just go about this problem like we usually do when we're solving equations. So let's go ahead and combine our like terms which is 72 and 24. And do inverse operations, which is subtracting 96 to both sides. And then lastly, we're going to divide, and that gives us that x equals 12. So we found x for this problem. And we are done since they're not asking us to find anything else.